Welcome everyone to the latest edition of the Reimagine Mobility podcast series. I'm here with Frank Noppel from Blueflite. Frank, you guys are in a space that definitely is redefining mobility. Definitely perfect for this podcast where we want to talk about how we reimagine mobility. So maybe if you could, Frank, introduce yourself, introduce what you guys are doing, what your vision is, and then let's jump in together. And I'm going to ask you a lot of questions on how together here we reimagine mobility.
Sounds good. Well, thanks for having me. My name is Frank Noppel, Chief Executive and co-founder of Blueflite, based here in Brighton, Michigan. The vision is that we believe drones will make a significant difference in the logistics sector. They offer much faster transport at a much lower cost than what is possible on the ground, which is a very attractive proposition to anybody who is in the logistics space. And there are secondary factors like much better access, no dependency on road infrastructure, running all electric without emissions, and so on. So looking forward to the conversation and your questions.
Very good. So let's jump right in. Let's define drones a little bit here, Frank, because I think some people may think, this is the stuff Amazon's been talking about, where my package, my new cell phone, my new mug, my new backpack is going to be delivered by a drone. Other people may talk about, no, we're serious. We're talking about larger crates, larger packages, things that may have to go from land to a offshore boat, an offshore drilling site, a hard and difficult to get to a remote site in the mountains. Define a little bit, and I'm sure it's not all of it, but define a little bit where you guys are in and what you guys discuss or mean with a drone.
Yeah, so that's a fair point. So you could structure the drone space by the size of the drone. It's probably the easiest and the easiest to comprehend. There is a point defined by regulation where the small drones and the large drones are being separated, and that is measured in weight class. That's 55 pounds or 25 kilograms total system weight. So we stay right at the mark, which puts us on the large end of the small category. It allows us to transport cargo in the range of 5 to 10 pounds. I say the range because there is an offset between the distance the drone can travel and the amount of cargo it carries. At the current technology level, we're talking about 30 miles, 40 miles, maybe 50 miles of range at the payload that I just mentioned. And this is assuming it runs on battery, right? So to define the drone in your words, it's a logistics drone carrying 5 to 10 pounds with distances typically 30 to 50 miles, running all electric, no emissions. And I think the important point to highlight, because there are many drone companies, and then we often get the question, why is it Blueflite? And I think the answer is very simple, because our drone was designed for the logistics use case. You cannot repurpose a drone that was designed for a different application and then expect it to work for logistics. You don't buy a race car and refurbish it and use it for your deliveries, right? So it has to be optimized and custom designed for the delivery application. And that's our strength. We have a patent on it. We cover the hardware and the software aspect. And we also focus on being the tech provider. So in the drone space, we do not operate the drones. I think the best analogy is an airline and an aircraft manufacturer. So we are the equivalent of the manufacturer, and our customers are the equivalents of the airlines in the drone space. And that's a very conscious decision. That's how we operate as a business.
And then, Frank, maybe the next question then is, when I look outside, sometimes I have neighbors that use a drone, okay? And you see drones sometimes when you go to the beach and people take pictures, videos, etc. They're remote controlled. Is the drones you guys are, again, as a manufacturer, provide to the operators remote controlled? Is it remote controlled up to a certain degree, but then also has capability of driving autonomously and come back to where it was sent from? Highlight a little bit maybe what we're seeing in that space as it relates to not the propulsion system or the range, but also the operations of it.
Yeah, no, that's important. That's very important, actually. The reason why this is an important topic is the unit economics, right? The most expensive part of any drone operation right now is actually the people flying it. And the way you described it with the neighbor in the backyard is you have a remote control unit that connects to the drone, and then that person will fly the drone, from a point A to a point B. And in a commercial setting, this is a salary you need to pay to that drone operator, right? And in the greater scheme of things, that's where you would have the highest cost. So it's in the best interest of the drone operator to have this drone run as autonomous as possible. And ideally, you have many drones operated simultaneously by one person to bring down this cost. And obviously, that is something we're aware of and is something where we design and develop our technology to have the highest level of autonomy going forward, because that defines the unit economics and the ability to roll out drones at scale. Right. And we're already at a level where we can program the autopilot through a very straightforward interface for this drone to run a certain mission that typically involves a takeoff location and then flying to a specified point where the cargo is delivered and then returning to the point of origin. And that's the most simple way of operating a drone, but there's more complex operations like the drone flying empty to a specified location, picking up a package and then delivering it somewhere else. So there's different layers of complexity, and each layer of complexity has different requirements on the level of autonomy. So I think the starting point is to keep it simple and move up in the level of complexity as technology and regulation and market acceptance matures.
Mm. So it's really, really similar then to what we talk in the mobility space, in the ground mobility space for autonomous vehicles on sort of this teleoperated or supported autonomous vehicles driving, right? Where you also have one operator sort of monitoring several different vehicles, and when or if they get stuck, they can jump in and help. Very interesting. So you're talking a little bit about, again, it's a battery powered system. We talked before about range. So every time in the automotive space, at least, it's about range and how long does it take to refuel or recharge. What do we see here with a drone when it comes back after it delivered, or it makes a pit stop somewhere else? Does it need to recharge? And if so, again, depending on range, we know that. But if it, let's say it's fully empty, more or less, what are we talking about from a recharging point of view? How much time is that?
Yeah, well, that's also a fair point, and it's a topic that's a little out of our hands because we rely on the technology that's provided to us by the battery manufacturers. So at the current level of battery technology, and mind you, there is big improvements happening in the battery space, but the flight time, and these are sort of average numbers, but you can expect about half an hour of operation out of a single battery charge. If you carry less payload or fly slower, then maybe you get more. And to recharge the battery, it takes roughly the same amount of time. And it's more down to how powerful your charger is, right? So if you have a fast charger, you can do it in less time. If you have a more standard charger, then it will take a little more time, but I would expect you will not cross the 1 hour. It will stay well below. There's two ways to recharge the battery. It's either you keep the battery on board the drone and you have an external plug and you plug in your charger equipment. And the second option is the faster one, where you manually take the old battery out and put a fresh one in, and then fly with the fresh one, and the old one goes on the charging rack. And I think here our approach is to offer both possibilities to our customers, because they may have different needs, and certain customers will accept a rotation time of a charging cycle between the flights, and other customers may want faster turnaround and therefore want to swap the battery. So I think it's important that we have the flexibility, and we've built it in our system, and both options are possible. To elaborate, and I'm going maybe above your question here, there are different energy carriers than batteries as well that are interesting for drones.
Which would be hydrogen, for example, or gasoline, or elaborate on that. I think that's an interesting point.
So both is the short answer. Hydrogen has a huge advantage. It stores a lot of energy in a relatively small volume and extremely light substance. So hydrogen weighs close to nothing. I mean, we know that lighter than airships back in the days were all flying on hydrogen. So it's a very light substance, but stores a lot of energy, a lot more than a battery. But you need a converter. So you need to somehow get this energy extracted from the hydrogen and turn it into electric power, so that you propel your device and feed the electricity to your motors. And there is already tech in place. There's different approaches, and they're now nearing a level of maturity where it becomes an attractive alternative. And it's not a question of whether it works. It's really more a question of where does the hydrogen come from if you were to run your drone on hydrogen. Now, the big advantage of hydrogen is the additional power allows you to fly much wider range, right? So maybe to trade simplicity in operation, because handling a battery is still probably easier than handling hydrogen. But if you wanted to fly over much more distance, then hydrogen becomes a very attractive alternative if you want to keep the drone at a reasonable size in our payload spectrum. And then second to hydrogen, like you alluded to, is also a fossil fuel power plant that converts through a generator the chemical energy in the petrol into power, electric power that's fed to the motors. And it's something that we don't see much interest, and we haven't pursued that path. Because I think the world is trying to get rid of petrol, and I think and drones offer this possibility. So we don't see much happening on that side, to be honest.
Let's jump into a slightly different area. You alluded to a little bit regulations, right? I mean, some people I've read about drones, are worried that whatever, in 5 or 10 years, all we're going to see is not the sun or the blue sky anymore. We're going to see drones flying left and right across everywhere. Can you allude a little bit? What do we expect as we look forward, and again, as we reimagine mobility in this transportation space here? Is there a lot of regulation already? Is there a lot of questions by the regulators? I don't know if the FAA is involved here or what, but shed a little bit of light on that space, please.
Yeah. Um, so when we talk regulation, it becomes quickly complex and global, and there are a lot of countries, and everybody has a slightly different approach to regulation. But what we can say on a global level is that regulation is becoming and advancing a lot more drone friendly. I think the regulators worldwide are recognizing the potential a drone can make to the economy, and we're talking about delivery drones, but not exclusive, right? There's other types of drones that have different applications. So regulation is advancing at a pretty fast pace towards enabling adoption or use of drones at scale. Now, if we double click on the US, then obviously there's one regulator, it's the FAA, and they started looking into drones many years ago, right? So drones are already flying. Drones are already flying for cargo delivery by multiple operators. And it's not a question of whether it's possible. It's a question of how much effort is required to get there for somebody who wants to get into the business of delivering by drone. And there are programs by the FAA and different approaches to use drones commercially. And at the highest level, it's becoming easier and easier with less and less paperwork and obstacles involved, right? And we can go into the more detail. I don't know if we have enough time for that, but there are frameworks being developed that streamline the process significantly, and are
that's
already
perfect.
being rolled out, and there's more to come for sure.
Frank, let's talk a little bit about short-term and long-term of the logistics space for drones. What do you see short-term? I think you've talked already a little bit about that. We have an idea. I think some of the use cases you already mentioned, but maybe you have something to add there. But what do we then also see long-term? In long-term, I mean between 5 and 10 years out, right? Short-term is more between now or in a year from now till 5 years from now. And then the next is, what do we see by 2030?
Yeah, so I think there's three factors that that you need to consider. The first is the technology. So what's available and what's the unit economics on those? The second is what is possible from a regulatory point of view. And the third that I think people tend to forget is what is accepted by the market, right? In terms of the use cases that are pursued by these various players. So let's start with the first one, which is down to tech. From a tech point of view, we're really starting to mature, and I think it's less of a question of what is possible. It's more of how much does it cost, right? And because of the other factors like regulation or where we see the applications of drones, the use of drones in logistics tends to be more geared towards where urgency is coming in as a factor. So in other words, where you have a high level of urgency attached to the delivery, because then the propensity to pay for a service to use drones is much higher. And we see that happening in the healthcare sector because most likely when you mean to move something in the healthcare sector, there is a level of urgency attached, and that could be medical devices or medicines or test specimens to laboratories, etc. So there's a lot of subsets of applications in healthcare, but I think healthcare in general is an industry that sees the adoption of drones at a high pace and is very attractive. Second to that is I would just frame it as sort of the industrial use cases. And again, there's many, many subsets, but that alludes to what you just said, like maybe going to offshore locations in maritime settings to deliver stuff to ships, and maybe it's less about the urgency, but the alternative mode of transport. So if you go to a ship, you need to go by dinghy or whatever is required. It's expensive, but the drone can do the same job at a much lower cost. And there are safety aspects as well that often play a role. And I think the third area that we see building momentum, a lot momentum, and this is down to how tech and regulations changing, is on the last mile logistics on the consumer side. This could be e-commerce, this could be your daily shopping, etc. And I think there's a lot happening in that space, and as the unit economics become more attractive, the adoption of those use cases is accelerating as well.
Okay, very good. In the automotive space, if I take a slightly different angle to what we've just talked about, in the automotive space over the last 5, maybe even 10 years for sure, maybe even longer before that, cybersecurity has become a much, much bigger issue, right? And it's I think on the one side about the safety of the vehicle, it's on the other side about the economic benefit somebody could gain from being able to totally disable all vehicles of a particular brand. I would assume, not knowing, but again, looking to you, that in the drone space, you have a similar issue, but we also have an issue of using these drones for the purpose of potentially hurting people by whatever means, or carrying or something. Again, maybe I've seen too many sci-fi movies or whatever, but really the topic here, cybersecurity. How big of a topic is this, Frank, in your space?
No, it's a big topic. And it's a very important topic. So at the first level, there's different ways of encrypting any communication with a drone. And this is typically handled through mobile networks, SATCOM, and there's different ways to do that. And the level of encryption is already very high in the signal flow. So the question is more about secondary levels of encryption, where we can fall back to two-factor authentication and very common processes, and that with each layer enhance the level of security with respect to accessing a system. So it's taken very seriously, and there's a lot of tools and technologies in place that can maximize it. And I think on top of that goes back to the first point, right? To what level is the drone required to operate autonomously? Because once it operates autonomously, then it doesn't require access through potentially, threats in the security system, because you don't need data flow between a ground station and the drone, and then it's more difficult to intercept. And so we're pushing the boundaries on all three topics, and constantly developing and working with our partners and suppliers to put the safest systems in place. And a lot of them are already based on what's available and proven. And now we're looking at what else is possible on top to make this even safer, right? And there are systems being used in the aerospace sector already, and they exhibit, or they carry already a lot of layers of security with existing systems that we can fall back on.
So 2 more questions. One for me, an interesting point that when we look at drones, right, we oftentimes, at least again in my neighborhood, I see them fly in great weather. I'm sure logistics type applications, they can't just only fly in good weather. They have to fly in high winds and in maybe snow, rain, fog. Tell me a little bit about that. Does that mean that, again, we have different drones for different applications, because some drones don't want to be, quote unquote, penalized with a slew of additional sensors to be able to have them fly in the worst of weathers, yet then they're heavier, and in good weather they would fly less far because of more weight. Can you shed a little bit of light on that, in that space?
Yeah, no, that's another very important factor, which comes down to how reliable is your system. And reliability is a very important topic in logistics, because any logistics operator, and in the end, it's the end beneficiaries, want a seamless service and want technology that works irrespective of what the weather is. Like if you're waiting for an urgent delivery and the feedback is, oh, sorry, it's raining today, we can't fly, then this is not acceptable, right? So we, as the drone manufacturer and design company, put a lot of focus on ensuring the highest levels of reliability in our system. And this comes down what I said in the very beginning. Most of the drone systems, specifically the ones that were not designed for logistics, they don't have that built in, right? They have limitations with regards to precipitation, temperature, wind, etc. So to bring this level of reliability up where it is accepted by logistics operators, you really need to think outside the box and solve these challenges through engineering. And I think that's where we as a drone OEM stand out, that we have a system that addresses all these challenges. And that's why our design is very different. We have a patent on it, and stands out over what else is available in the market.
And then last question, nothing to do with drones, but what's the next car you're going to buy and why?
Well, I'm more of an aerospace guy and not a car person. I wasn't prepared for this question, but my natural inclination would be I'm probably currently driving my last petrol car, and the next one will be electric.
All right, very good. So if you could, you would take a drone or a helicopter to work, if that's possible?
Yes, I'm a private pilot, so I do sometimes fly if I get the opportunity, which doesn't happen very often anymore. And going via the air has certain advantages. It's much faster. If the weather is good, can be a lot more pleasant. I hope that in our lifetimes we see airborne transport becoming a major means of transport, whether it's with or without people aboard. So
absolutely. Thank you so much, Frank, for your time today and for introducing us to drones and the logistics, to introducing us to your company, Blueflite. Congratulations to some of your recent financial awards. Certainly a great thumbs up for what you guys are doing. And again, congratulations and good luck going forward.